All right, 1201. We'll go ahead and get this kicked off. So, welcome everybody. This is our Q1 Lunch and Learn. Thank you so much for joining us today. We're going to be covering. I can recognize a lot of friendly faces, friendly names on the teams. So, thank you for joining us. Today, we're going to be talking about the implementation of large language models in a workflow for enterprise GIS. It's going to be starting off with Zach, who is our summer intern for the 2024 summer. And he is going to walk you through what he did and what he learned. And shortly after that, we have um, that kind of technical walkthrough through a resource that's available through our GitHub. That's already pasted in the meeting chat if you want to take a look at that ahead of time. And yeah, and let me just introduce Zach very quickly. Zach is so he was our first ever PUG summer intern. So thank you so much, Zach, for offering to do that. We will be having applications that we'll put on LinkedIn,
Okay.
or just a short link that way anybody for this upcoming summer. And Zach did his undergrad at UH in computer science. He is currently doing his graduate degree at um, Penn State,
Yep.
and go ahead and take it away. We're so excited to hear what you got to say, Zach.
Okay. Thanks, Hilario. First of all, welcome, guys. I'm calling this the Data Atlas Expansion Project because we're mainly focused on looking for new feature layers, feature services to add into our Data Atlas. I have a little about me section here, but Hilario kind of covered this just now. Currently going to Penn State. Hopefully, I'll be finished in or sometime this year, towards the end of this year. But I have my LinkedIn page right here, so you guys can look me up on LinkedIn. Um, we'll start off with a problem statement. So currently, the data atlas doesn't have the latest, most relevant data, and we're looking to find and curate new content for our data atlas. And the main thing we're going to be looking to avoid is adding a bunch of junk into our data atlas because that would just kind of make things useless. We want to find highly relevant content that we can use. So we need to keep it that way. So let's start off by defining what the data atlas is. I'm sure most of you are familiar. It's an online repository hosted in ArcGIS Online with a bunch of feature service layers. Over here on the left-hand side, you can click on these and brings up a map view where you can view the feature service. You can look at the attribute table. There's a download button for these feature services, and you can download the data and overlay them in ArcGIS Pro with your own content. What's more important, on the right-hand side over here, we have different PUG topics, and these are going to form the basis for keywords that we're going to be searching for in our CSV files that you'll see later on. But our solution statement, um, we're going to be using two scripts. One is kind of a pre-processing script where we're going to be looking for junk, filtering out as much junk data from these CSV files as we possibly can before we feed the output of that script into a new script using generative AI. And the model I used was GPT 3.5 Turbo, but we'll be kind of looking at that later on. This is just our little project workflow. Manually filtering data on the Living Atlas and ArcGIS Online was another component of this project, but to save some time, we're not really going to be covering that. Mainly going to be focused on expanding on these two scripts that you see down here. So first off, I just wanted to kind of look at the structure of our data and these CSV files. We've got a lot of feature layers contained within these files, over 160,000 feature layers. And you can see how they're structured down here. We've got our title, URL, type, tags, description, so on and so forth, columns. And we're going to be using a regex to search this input for keywords that are related to keywords that we find in our PUG data atlas. Um, so this is kind of the workflow for the first script. We've got our input folder path. Right off the bat, we're going to be creating a data frame and initializing a list to hold relevant CSV entries. We're going to be reading the data frame and checking the input for relevant tags with this text parameter that you see right here. And this is kind of the process that we're using. We have a word boundary, regular expression. We have a tag set full of keywords, and we're going to be trying to match words from our input to a keyword in our tag set. We also have some problems. So some keywords that we're looking for, parcels, for example, are attached to things like bike path parcels, and we don't want bike path parcels in our output. So we have another function that's going to be checking for irrelevant tags using the same process. So if the CSV entry contains a relevant keyword and it does not contain something that's irrelevant, we're going to be adding that row to our relevant rows list, convert that to a new data frame, and then we produce a new collection of CSV files from that. And these are the results from our first script. We managed to filter out approximately 94% of all of the input data, which is going to be very important. This is going to save us a lot of time later on and cost when we're using our language model. So some concepts and definitions for our second script. I mainly used GPT 3.5 Turbo. It's just a general purpose text generation language model. We're using LangChain, which gives us access to these different workflows that you see here. The main workflow that we're going to be using is tagging. And Hilario, thanks to Hilario, he provided a nice structured classification-based model for tagging our data. So we're going to be giving it an energy aspect tag, which is going to be determined by the language model based on the input that it reads from our CSV files. It's going to be rating these entries in terms of on a scale of 1 to 10. So with 10 being the most relevant to the energy aspect that it provides. And then we're going to have the language model choose from a list of tags that we provide to it. And this list comes straight from our PUG data atlas topics. So that's how we're going to be structuring our output for this. So our second script, we've got our input CSV files, which is the output from our first script. We're going to be reading the description tags and other columns from this data. This is going to be passed to a prompt template, and this is combined with our language model. And the language model then processes this text input, and we get our energy aspect, our relevance score, and our PUG topic tag output from our classification-based model. And all of this forms our tagging chain right here. Then we provide a relevance score for all of these, and we select a relevance score between 7 and 10. We want entries that are highly rated, and we're throwing out anything that's rated between 1 and 6. So then these get written into new CSV files. So this was my output for the second script. GPT 3.5 Turbo only managed to filter out 17% of all of this data. I did run GPT 4.0 Turbo for one of the files, and I filtered out 70%. So really big difference there in terms of the quality of the results. But GPT 3.5 Turbo is a lot cheaper to use. So that's why I used it. Um, so here's my results using GPT 4.0. And if we're going to be putting this data into our data atlas, I would recommend running 4.0 for every single one of the files, just because of the quality of the output that you get. But it's mainly these two things down here. You get more contextually relevant output and more reliable structured responses. And you can kind of see that reflected in this output screenshot right here. So we have our energy aspect column up here. We've got our energy related rating right here, and we've got our tag from our list of tags in this column. But GPT 4.0 is doing a really good job, um, classifying all of this data for us. For example, I had to look some of these up. I told Hilario yesterday, I didn't know what plugging programs or surface casing were, but it turns out they are related to wells. And you can kind of see over here um, in surface casing, right here, it's finding the word surface casing and tagging it or giving it the correct energy aspect. It rates it, and then it chooses from a list of tags that we provide to it. So in this case, it shows that it was most related to wells, which I guess surface casing kind of is related to wells. So it checks out pretty well. But some key takeaways, pre-processing saves us a lot of time and money. If we didn't do the pre-processing step, we would have just been dumping 162,000 uh, entries into our language model script, making 162,000 plus API calls, which would have cost a lot of money and taken a lot of time. Um, we can apply this workflow to process any metadata, uh, and we save a lot of time and improve efficiency this way. And the model that you use, in this case, I use two models, GPT 3.5 and GPT 4. And the prompt you use matter a lot. You need a very detailed prompt, which I didn't really cover to kind of save time on the presentation. But these are two things to keep in mind if you want to experiment with these scripts yourself later on. So some next steps, maybe we can automate some web searches to curate content. There's always new content on places like ArcGIS Online and GeoServer and so on and so forth that we can find. And we can use this process of classifying content with a language model. And this is just kind of an article that Hilario sent me a while back that kind of gives some details on the process of doing that. But anyway, that's all I have for you guys. If you want to look at the code for the two scripts I wrote, they're both on my GitHub page. You just go to that URL and you can click on the repos, click on the .py files, and copy the code and use it, play around with it and do whatever you like. But anyway, appreciate you guys coming out and checking out the presentation. I'll hand it
Yeah,
back to Hilario.
thank you, Zach. This is going to be our time period for questions. So if you have any questions, you can feel free to unmute or you can put your question in the chat. We can answer it. I also want to talk a little bit about the initial ask was, we scraped all these links. We need an intern to go through and manually look at all of them and to see which ones are relevant. And immediately Zach and I were like, okay, there's a better way to do this. So um, that's really where the spirit of this came through. And just my first question for you, Zach, just to kind of get the first one out there, is can you get some give us some context and like how long it took to run through one of the files and to go through all the API calls for that. Can you talk a little bit more about that?
Yeah, sure. So without multi-processing, it takes a lot longer, maybe So to process 17 files with GPT 3.5, I think it took me, without multiprocessing, 2 or 3 hours. It was took a long time. With multiprocessing, um, I'm pretty sure I used 4 worker tasks. So I was processing 4 files simultaneously. Maybe it took 30 minutes. It's been a while. It's been months. So yeah, you really need to use multiprocessing to cut down on the time. And it would obviously take a lot longer if you're, processing 162,000 entries. If you don't do that pre-processing with the first script. So yeah, that was for 10,000 plus entries. Um, so it was making 10,000 API calls. Took about 30 minutes or so.
Thanks, Zach. Are
Yep.
there any other questions? So there's one in the chat. It says, if someone wants to get started using the GPT models, do you have a suggestion for a website where they can go to learn about it? What's the starting point? So that actually ties in really well to our next part, which is where we're going to do a technical deep dive into one of the notebooks that we have. So thank you for the question. We will get there in just one second. I have one last question for Zach. So given what you have learned, how are you going to apply this in any future workflow for yourself?
So I'm using an entity recognition model for my final project um, for Penn State. I think I told you about it, right? Well, probably several times.
Yes,
But
no, but tell, please enlighten everybody.
so I'm mapping um, conflict zone related data that I'm scraping off of Telegram. So usually this data has coordinates attached to it. If it's like an FPV drone attack, it'll have like coordinates attached to it or something. But if it's geopolitical information that I'm scraping off of Telegram, usually it'll have like you know, a leader gave a speech at Davos, Switzerland, or in Paris, or something like that. So it'll have the location name, but it won't have any coordinates attached to it. So I'm using an entity recognition model on Hugging Face to read through this input text and tag things like locations. And then I'm using GeoPy to attach a set of coordinates. So if it's like Paris, it'll attach a set of coordinates to the location Paris where the speech or whatever uh, was made, and then I can map this. But yeah, that's kind of how I'm using this for my final project. I haven't had a whole lot of time to work on it, unfortunately, because of the class that I'm currently in right now. But
Yeah,
yeah,
no,
when this is
that's very
over,
understandable.
yeah, when this is over, I'll have a lot more time to work on that project. And I'm also using I'm mapping this in Unity. So there's a Maps SDK from ArcGIS for like Unity and Unreal game engines, and you can create some really cool graphics and things like that. But yeah,
Awesome. Thanks for sharing that, Zach. We had one more question from Nick. Have you compared your model pricing to any new engines like Google Gemini? I know the price token has drastically come down in the past few years.
I haven't used Google Gemini. Haven't compared the pricing. I know there's a bunch of general purpose models on Hugging Face that are free, which we didn't use. Although I don't know how good they are. They're probably not as good as like GPT 4.0. And also, China has their new language model, DeepSeek, I think it's called. But
Yeah,
yeah, haven't had a chance to use that yet. Um, but anyway, thanks for the question.
awesome. Yeah, thank you guys. Thank you everyone for the question. We're now going to move, and Zach, great job. Really want to give you an little bit of a virtual applause.
Thanks.
You did a great job with your presentation, and we really appreciated your time
Yeah.
that you spent with
Appreciate you
us.
guys all coming out, checking it out.
So, can everybody see my screen?
Yeah. I'm going to go ahead and mute myself. All right.
Okay.
All right.
All right. So, given that everybody can see your screen, so this is available. The link is already inside the Teams chat to this GitHub page. And what this notebook is just getting started with large language models. And hopefully, at the end of it, you can, be able to apply this very quickly, for personal or for work use. So this is going to be kind of like the basic structure that did the tagging for what you saw in Zach's presentation. So I'm just going to slowly scroll through. I tried to put as much a lot of comments in here, so I'm just going to hit the high notes, and I highly encourage you to go through it. And if you have questions, you can of course email us and or ask. Yeah. So we're going to go ahead and start by importing from our environment variables. So the ones to point out are the Open API version. Oh, I also want to preface that I used Azure OpenAI in order to do this. That was just what was most accessible to me. Um, as Zach noted, he used ChatGPT. So it just you can use different models, but this is just the environment that I used. It's only going to vary the workflow very slightly. And what I really want to point out is, we have one cell that's doing all our import statements, and we're getting our environment variables. And the very next cell, we're running our invoke, which is, tell me a joke. And right away, we are able to use our, y- our, our large language model right away. And you can see our result. So just to kind of, bring that into context again within 2 lines, we are just highlighting our endpoint, our deployment name. We're using our key, and we instantiate it. And then the very next one, we're able to invoke it. Tell me a joke, or what is a provide Python code that can do this in ArcPy. Insert whatever. It just as you're very familiar with the GUI for it. This is we're now able to programmatically ask a question. So going through, we have our content, our output, I should say. And so our joke is, why couldn't the bicycle stand up by itself? Because it was too tired. And you can see there's a lot of additional information that's also provided. So in the output breakdown, you can see the text, you can see the response metadata, mostly looking at the token usage. This is going to correlate to how expensive it is. And you can have other sorts of information that can be helpful for breaking down and better understanding the outputs that you have. All right, so there you go. You do that, you got started with it. Now let's try to do something with what let's try to take it a step further. So I actually have to edit this. This is a more commented version of the cell I just passed. So next we're going to work on our classification. So we're going to start with our Python class. And this is, if you take what was in Zach's presentation, he had a really good slide that was showing, what we were looking for. And to just hit that again is this um, text energy related? How relevant is it? And what category does this fit in? So as it goes through each our CSV file or a pandas data frame, it's going to be assessing that, and it's going to be giving a result for it. So for the is energy related, we're going to be getting a Boolean, and this is our prompt for this portion. And it's indicating whether or not it is associated with any specific part of the energy sector. For the second one, it's evaluating the text relevance to the key energy categories. And if it's not relevant, it gets a minimum score of 1. If it's very relevant, it gets a maximum score of 10. Next, we're actually classifying the energy category that falls in. So it is, this large language model is finding out, based on the text that input, that this is related to infrastructure or imagery or seismic or geology. Of course, it can, touch many different things, but we're kind of leaving it up to itself to give it 1. Next is our tagging prompt. So this is kind of giving the general instruction. And then um, we create our new instance. And this is kind of going into, we're using lane chain as our framework to create this chain. So that's just a fancy way of just, we're putting it all together. We're putting our tagging prompt, which is this very specific framework on, is it energy related, the relevant score, the energy category. We're tying it with the LLM. This is, of course, where you can change, given if you have 4.0 or if you have any other model that you want to use, you can change it. And then now we have our chain. So our first input text. The new geothermal plant will significantly enhance the renewable energy capacity for the region. It involves drilling wells, et cetera, et cetera. So we're going to invoke our chain, and our result is that it is energy related. The relevant score didn't give it 1. Energy category didn't get 1. So not a great example, but I'll go in there and tweak it a little bit. And so here we are, so now we have something that's a little bit more useful. Now let's try to get from let's try to pull open a CSV file that has all of the different potential layers that we've scraped that can be ingested into our data atlas, and let's see what it looks like. So now we have the title, URL, type, tags, description, thumbnail, relevant score. So these are all just default to none and false. And so we're just trying to see, is the URL valid, energy category, relevant score. Going through. Here we're matching it up so we can get the specific output for like, is energy related, what's the relevant score, the energy category to fit appropriately into our data frame. And then these change. I apologize, I uploaded the wrong one. But this, as you've seen in Zach's presentation, this does actually give you a relevant score energy category valid URL. So apologies there, but I hope that this does bring home the idea of how this works. And to kind of wrap up this notebook, what we hope to show you through Zach's presentation, as well as through our little quick start notebook that will edit a little bit, that this is a workflow that you can use for the metadata within your enterprise GIS system. So perhaps your enterprise GIS system has layers that you're not sure how relevant it is, or if it's even organized or categorized the right way. And perhaps you already have a workflow that is addressing that through pretty programmatic way. Well, this can be that last step that can help to bring it to add an additional logic to it to appropriately organize it and elevate your workflow. So this can go into metadata reading, semantic analysis. It can enhance metadata. So if you changed your system prompt to be very specific in what you want your metadata to look like, then of course it can do that, and it can do that in a structured way. It can classify it. If you wanted to, check for data consistency, all of that are possible solutions that you can use with a large language model. Um, and some just very similar but different additional implementations would be automated documentation and training and tutorials. Um, Predictive analysis, not the biggest fan of. You could, but I'm personally not the biggest fan. But again, just to as a final conclusion, uh, LLMs are you know powerful tools that can help elevate the workflows that you probably already have. They're not the end all be all solution, as that demonstrated. You, just running LLM on all of your files would be very expensive, and you can argue how useful that would be. However, and coupled with a current solution, it could prove to be very, very helpful. So are there any questions? We're going to update our GitHub. And we're also going to put Zach's presentation and this recording that we are doing now, we're going to upload into YouTube, and that link will also be accessible from our GitHub. Pending any questions, where's the GitHub link? Okay, I'll paste it. Here we go. And I will push it. I will push working. I will edit it to where we have a working one. My apologies about that again. But pending any questions, that concludes all the material that we have. Okay, so we had a chat. It seems the workflow is pretty flexible and can be repurposed for your own ArcGIS Online or portal content tagging, or for more extended purposes. It's a great building block for a bigger scope. With ArcPy and REST APIs, you can read items, services from ArcGIS Online portal, define your own tags, categories, attributes, and run the script against them, update your content on the fly. Very true, and that's exactly what the dots that we're hoping to connect and show. And thank you so much for pointing that idea out. In our next intern project, we're hoping to do some of the automation, use the ArcGIS Python API in order to do that for our Energy Atlas. And so this is a shameless plug that if you have anybody know of any college students, undergrad or graduate, to please give them the link to our LinkedIn page to just keep a lookout. Very shortly, we're going to start putting out our request for interns, and that's doing the next steps that Zach suggested is going to be what our next steps are. We hope to see you at the Esri, or as I was, we hope to see you at our URGIS 2025, which will be from April 29th to May 1st. And we hope that you'll have a great day. Thank you for spending your lunchtime with us. We really appreciate it, and we'll see you next time.
Thanks, guys. Bye.